Hello and welcome to Logistic Regression in R. This is where I will give you a very quick walkthrough of how to do or how to train a logistic regression model using the Tidy Models framework. Now, this video will be pretty brief, and the reason for that is, every one of these algorithms, every one of these models that I'm going to be teaching you, they can have pretty much their own course, right? They have a lot of detail in terms of how you can play around with them, how you can, build workflows around them, how you can generate different performance measures, and how you can interpret different results for different problems, so on and so forth. So there are a lot of case studies that we can go through for each of these algorithms. So, that would take a lot of time, and that would prevent us from as many models as we're going to be going into, because, as we've already learned quite a bit in this course. The approach I'm following is I'm giving you everything you need to know theoretically, right, for each model in the introduction video, in the introduction presentation, like I did for logistic regression. So I gave you, all the different performance measurements you need to know, like ROC and that kind of stuff. But we might not necessarily see all of them in the practical application because, you might need different ones depending on different problems and that kind of stuff. So in this video, where I actually show you how to apply the model in R, I'm just going to be building for you a very simple workflow from start to finish that you can, also try on your own. But given the knowledge that I also gave you in the introduction video, this should allow you to further pursue and look into other material and references, extending your logistic regression applications in R. So again, this is not meant to be a comprehensive logistic regression application in R. It's just one application, and there are so many different ways you can go about doing it, and it's up to you to go and find tutorials and other examples and case studies, or just to play around with it on your own. So I just want to give you that caveat because, otherwise we'd never be able to finish this course, and, no other course would actually go into that much detail as well, right? So pretty much this course will give you a foundation for all these models. And then if you want to, for example, pursue logistic regression more, now you can go and search for logistic regression in R examples in Google, and you'll be able to understand those examples. And that's how you'll continue to grow your knowledge. So for our example in this video, we're going to be loading, the typical tidy R, ggplot2. We can load the correlation package. We can load our sample, recipes. Now I'm loading all of these one by one just so you can see explicitly like what packages we're going to be using. But know that you can load all the tidyverse packages by loading the tidyverse like so. Or you can load all the tidy models packages by loading tidy models like so, but you have to install it first, right? So in our case, I'm not going to, because we don't need all the packages, but these are the ones I'm going to be using. But just keep that in mind. You don't need to always explicitly load packages into your environment when you're dealing with the tidyverse and the tidy models packages. So let's go ahead and load these. We have no problems there because we installed them already in the previous videos. Now let's start off by first picking the data set we're going to be working with. So generally, and this is not just in R, just other environments for machine learning, there's a data set that's very commonly used for teaching or learning classification, or specifically logistic regression, which is the first classification model that one generally learns. And that data set is called Titanic, and it should be built in. And if not, let's see if there's a package. So let's go ahead and install. Yeah, so there's a package called Titanic, and you can load it, and then you can be exposed to. So the Titanic dataset is a very famous, very classic dataset, and it essentially contains data on. In fact, we can even maybe just pull up documentation. Yeah, there we go. So Titanic passenger survival dataset. So it's a collection of data on the passengers that were aboard the Titanic when it sunk, and different attributes concerning their voyages, their ticket numbers, or if they had any children, that number of different features, for each passenger, and whether or not they survived the Titanic sinking or not. And so the aim, obviously, is to build a model in which you can predict whether a certain passenger would survive or not based on the other features in the data set. So this is a very classic, even if you're familiar with Kaggle, very famous platform by Google for machine learning competitions. They also, I think, start you off right off the bat using the Titanic data set. And, for all our purposes, it's an actual data set, it's a real data set, and it's complex enough, and it has all the intricacies and the complications of a real data set, like missing values and all of that kind of stuff. So it's a very good data set, and you should be pretty fit or pretty ready to continue with other data sets if you can really understand how to solve, the Titanic classification problem. So what this package does for us is it just conveniently gives us a validation and a test data set. So, let's go ahead and Titanic train data. So, there isn't much other information, but you can see the different, and you can see that it is actually from Kaggle. This package does pull the data directly from Kaggle. So these are the different columns: passenger ID, whether or not they survived, P class, which means passenger class, name, sex, age, SIP, which is the number of siblings, spouses aboard, parts, number of parents or children aboard, ticket, fare, cabin, embarked. So if this were going to be a more comprehensive case study, we could actually go into some, exploratory data analysis and explore this data and understand, which of these features might be important and not, and that kind of stuff. But our aim here is just to showcase, a typical logistic regression workflow. And you've already, learned how to do exploratory data analysis and data preprocessing and all of that. So I'm not going to spend time on those aspects of solving a logistic regression problem. I'm just going to focus on the technicalities of actually doing a logistic regression problem. So let's take, and we can see here, so they've basically created a test train split for us. But what we're going to do is we're going to create our own. So let's take as data, let's take what they put aside as the training data. And then we create our data split using our sample. So initial split, we create an initial split on the data, and then we create a training data set using training from our sample on data split, and then we create a test data set using testing. And I do realize that I spelled that wrong. Why am I saving? Data split. Okay, and we can actually start off by skimming our data just so we can see what we're working with. So let's go ahead and run that, and we've created all these variables, and here we go. We have a nice skim of our data. So we can, right off the bat, we can see that it has 669 rows and 12 columns. 5 of these columns are characters, are of the type character, 7 are of the type numeric. So, we might want to convert this into factors, right? And then all the columns are complete except for the age column. So, this is only 80% complete. There are 131 missing ages out of 669. And that's it's not an insignificant amount, right? It's not something we can just ignore. We can't just eliminate those rows. So we have to come up with some way of imputing the missing values there. So that's something we have to think about. But aside from that, we can just apply some normalization here to just standardize everything. And then, for the names, we can ignore. So names will be more like an ID column. Name shouldn't play any role in whether or not somebody survived or not, especially since names are unique, right? So we can ignore that column. Sex is very important, obviously, and this is something we can encode. We can vectorize this column. So we can create a column called like male. If the value is 1, then that means that the passenger is male. If the value is 0, then that means the passenger is female. So that's how we can vectorize this column. Ticket, ideally, if this were a more in-depth case study, we would have to look into what ticket is and if there's any structure to the way the ticket numbers are generated. such as where the passenger is coming from or how much they paid for it and that kind of stuff. Cabin, again, likewise, we'd have to do some exploring, and embarked likewise, but there's only 3 unique. So I'm assuming there were 3 ports that the ship sailed from, and so we can just vectorize this as well, right? So, this just gives us a very quick understanding of the data we're working with. And now let's create our data processing, pre-processing recipe. So let's create a recipe, and we are defining, right? We can view train as well, just so we can see the data, right? So, okay, so embarked, we were right in assuming that there are only 3 possibilities, and so we can just vectorize that. So cabin appears to be an issue. I don't know why here it says complete. I'm assuming that there are like empty spaces or something, but I think we can just eliminate, for all our purposes, we can just eliminate this column. If you would want to, like, for some more advanced data analysis, you could try to discover some pattern or some association between these and the rest and try to apply that into your work, but no need for this class. And then same with ticket, right? Fare seems to be something that's pretty important. Anyway, so again, I'm going to leave it up to you to observe this. Survived is essentially the 0 or 1, right? Corresponding to whether they died or not. And so that's our outcome variable. That's what we're trying to predict. We want to predict, based on all these other columns, whether or not a passenger was able to survive or whether or not they died. So we're defining in recipe, survived is the outcome variable, and the input variables are all the other variables. And we're using the train data, right, that we defined up here, the train data set, because later we're going to be validating with the test data set. And then the first thing we can do is we can convert the survived column into, actual classes. So let's say, we're going to use the step mutate. And remember, obviously you can take a data set and you can use mutate from dplyr to change or a column or add a column, that kind of stuff. But here we're defining a pre-processing recipe, a recipe that we want to be able to apply directly to other data sets within a machine learning workflow, a model fitting workflow. So that's why we're relying on the recipes, packages, functions that all start with step. And that's why we're using step mutate, okay? Just want to remind you of that. So survived, we want to mutate survived. And if survived is 0, the class would be died, and otherwise it would be survived, okay? Now, we want to then convert this into a factor. And so let's use the string to factor function, or the string to factor step from the recipes package, to convert survived into a factor. And then we can remove the columns we said would not be useful for us. So we can remove passenger, and RM just stands for remove. Passenger ID, we can remove name, we can remove ticket and cabin. Because remember, those columns we said would be too much effort at this point to really understand what's going on, and we don't need to, we have enough data that we're hoping we can successfully predict something using them. So we're just going to remove those for now, or for this model. And then we said we have to do something about the missing ages. So let's just go with mean imputation. So we're just going to be imputating those values that are missing using the mean of the column. Nothing too advanced, nothing too sophisticated. We could use something like, KNN impute, which actually uses k nearest neighbors to cluster the different instances or different passengers, and then, finds an average of those and then imputates those passengers belonging to that cluster, so on and so forth. So that's a little bit more complex. No need for it here. By the way, we will be going into KNN in one of the future sections. So instead, we're going to just be using mean impute, and we're going to be doing that on the age column. And then we want to vectorize the remaining character columns. So essentially, we got rid of ticket and cabin. So we want to vectorize embarked and sex. Okay, so let's go ahead and and do that, remember we use the dummy step. So we're creating dummy variables from these columns. So we want to vectorize all the nominal or the categorical columns, and we want to exclude the outcomes. So we don't want to touch the survived column. We've already done what we want to do with it, so we're excluding that. So this, how does recipes know what this refers to? Because here we specify the outcome, and that's how it knows, okay? And the minus, remember from the tidy verse and the plyr and the grammar of data and that kind of stuff, we know how to use the minus sign to remove a column or to exclude it, right? And then let's use a step called ZV, which is essentially, let me pull up the documentation for you. So this is essentially a zero variance filter. It creates a specification of a recipe. Okay, we know that we're using a recipe. It will remove variables that contain only a single value. Okay, so steps like this, you'll start getting an intuition for what's needed and what's useful where and that kind of stuff. But in our case, you can just trust me that in this case we're going to be, for all the predictors, we're going to apply the ZV step, and then we want to center, right, all the predictors, because now they're all numeric variables, so we want to center them around 0. So basically we're standardizing and normalizing, and then we want to scale them. Okay, and again, you can pull up the documentation for each of these, and also whenever you see somebody applying a certain step and you read the documentation, you understand what the step means, but you don't know why somebody would choose to do that for this particular problem or that kind of stuff. Go and search on Google. There are multiple different forums like Stack Overflow that people have asked questions like this numerous times, and they've gotten very good replies, everything from high level statistical mathematical replies to more easy to understand using layman terms and that kind of stuff, those type of replies. So don't hesitate. This is the only way you'll get good at machine learning. You have to experiment, and you have to see a lot of other people and how they solve problems, and then you have to question why they do it that way. And you have to, it has to bug you. You have to go and Google it and look it up and try to understand, maybe read a chapter from a book, watch a video here or there, and just try to understand, what each step in the whole workflow, not just in the pre-processing workflow, but in the whole workflow, what application of each step is and why that individual chose to do it that way and not another way. So that's how you will get good at machine learning. So let's assign this to data recipe like so. We misspelled survived somewhere. That's where we misspelled it, so let's fix that. Okay, so now we have data recipe, and here we can see the details of the recipe. So we have one outcome variable, which is survived, and all the rest are predictor variables. We apply a variable mutation for survived, and then we factor variables from survived, and then we delete terms, passenger ID, name, ticket, cabin. Then we do a mean imputation for meaning average, so we get the average of age, and we apply to the missing values. And then we do dummy variables from all the nominal variables, excluding all outcome variables, and then we do a zero variance filter on all predictors. So this is what I mean. In this case, you can go and search on Google, why or in which situation would you apply a zero variance filter for a classification problem, for example. Okay, and then you'll see, tons of people have asked this question, they've gotten replies, and so that's how you'll really get good at machine learning, right? Reading those replies and understanding that why it was used. So what I'm trying to convey to you in this course is that it's really easy, okay, using R, using tidy models to actually train a model. You have direct access to all of these models and steps and all of this kind of stuff that normally you would have to do on your own from scratch. Traditionally, that's what you would have had to do. But now it's all very easy. So now you can just focus on the higher level